In this problem, we are given that V of t is equal to 100 times sine 500t minus 23 degrees volts. We need to translate the voltage into the cosine equivalent. Well, the only thing for a cosine equivalent that's going to change is our phase angle. If we look back at the previous problem we did, playlist link below, we can see that this is the only thing, again, that it will be changing. So that means our 100 in front of our sine, this is our V max for our sinusoidal wave, is still going to be 100. We know that our 500t, our omega, will not change. So we will have a 500 here before our t. Again, the only thing that's going to change is our negative 23 degrees. Now, if we draw a graph, we can see this a little bit more clearly. So if we draw a sine graph, we know it starts at 0 right here. It goes up and down and up, and then if it were to go this way, it would go down and then up and then down, something like this. Now, that's for sine. If we draw it for cosine, we are going to have something that looks like this. We start up, and then we are going to go down, and then up, and then down. So what we can see is that our cosine, this is our cosine, is about 90 degrees behind our sine. Since it's 90 degrees behind our sine, we're then going to have that our phase shift is going to be equal, this is our cosine phase shift, equal to a negative 90 degrees plus a negative 23 degrees. This is constant, this negative 90 degrees. Now our negative 23 degrees, that's going to come in because we have this phase right here. That's why it's being added. So if we add these two together, we are going to get negative 113 degrees. Now we need to find the RMS value of our voltage. We can look at the formula in the notes that's linked below in the description, covers the entire coursework, that our VRMS is equal to our Vmax, and Vmax and Vp, that's interchangeable. So we're going to have our Vm over the square root of 2. Our Vm is our Vmax, and we know that our Vmax is this 100. So we're going to plug our 100 into here. We're going to say that our Rm is 100, and then we have a square root under this, and this will give us our RMS. So our answer for here is going to be 70.7 VRMS. Now we're asked to find the voltage Vt at t is equal to 5 milliseconds. We can solve this either for cosine or for sine. I'm going to do both just so we check that everything works out correctly. And this is a good way to check for things. First, I'm going to solve for sine, and I'm going to do this in black. So our V of t, t being 5 times 10 to the negative cubed, because a milli is 10 to the negative cubed, is equal to 100 times our sine times 500 times the time, which is 5 times t to the negative cubed, minus, and here we're solving for radians. So we're going to convert this negative 23 degrees into radians. We're multiplying this by pi over 180 degrees. And now we're going to carefully plug all of this into a calculator and make sure the mode for our calculator is in radians. And if we do this, we're going to get approximately 86 volts. Now we're going to solve for our cosine in gray. We have V for voltage, and then 5 times 10 to the negative cubed is equal to our 100 times our cosine, and in here we'll have 500 times 5 times 10 to the negative cubed minus, and then this is our degrees in here that we're going to convert to radians, so it's a minus 113 degrees times pi over 180 degrees. And if we carefully plug this into our calculator, again using radians, we are going to get 86 volts approximately. So that has to be the answer, and we did the rest of the problem correctly. That is how you would go about solving this problem. If you want more introduction to circuit analysis, there's a playlist as well as notes for this entire course in the description below.